Good day, everyone. Welcome to Seven Wars.
Today, we're gonna tackle Charles and Boyle's law. But first, what are these laws? Boyle's law states at a constant temperature, the volume of a given mass of an ideal gas is inversely proportional to its pressure. While Charles' law states at the constant pressure, the volume of a given mass of an ideal gas is directly proportional to its absolute temperature.
An example of Boyle's law are carbonated drinks. For example, this Coke, and this is how it applies. The carbon dioxide gas is dissolved in the Coke under pressure. The volume of the gas is small. When you open the bottle or can, the pressure is released. This decrease in pressure allows the carbon dioxide gas to expand. As the pressure decreases, the volume of the carbon dioxide gas increases, and this is why you see bubbles forming and rising to the surface.
Another example of Boyle's law is a lung. A lung diagram illustrates the structure and function of the lungs by number 1, expansion or inhalation. When the diaphragm contracts, the chest cavity expands, increasing the volume. According to Boyle's law, this increase in volume reduces the pressure inside the lungs, allowing air to rush in. 2, contraction/exhalation. When the diaphragm relaxes, the chest cavity contracts, decreasing lung volume. According to Boyle's law, this increase. Number 2, contraction or exhalation. When the diaphragm relaxes, the chest cavity contracts, decreasing the volume. According to Boyle's law, this decrease in volume increases the pressure inside the lungs, pushing air out, like this bit.
Mathematically, this can be expressed as P1 V1 equals P2 V2, where P1 and P2 are the initial and final pressures of the gas. V1 and V2 are the initial and final volumes of the gas. Boyle's law has several important implications. Number 1, inverse relationship between pressure and volume. As the pressure of a gas increases, its volume decreases, and vice versa. Number 2, constant temperatures. Boyle's law only applies if the temperature of the gas remains constant. Number 3, ideal gas behavior. Boyle's law assumes that the gas behaves ideally, meaning that it obeys the ideal gas law.
A hot air balloon is a great example of Charles' law, as the volume of a gas is directly proportional to its temperature at constant pressure.
Here's how it works. Heating the air. When the air inside the balloon is heated, its temperature increases, causing the air molecules to move faster and spread out. Expansion. As the air expands, the balloon inflates, demonstrating Charles' law in action.
As the heated air inside the balloon becomes less dense than the surrounding air, the balloon experiences an upward buoyant force, causing it to rise.
The hot air balloon model illustrates the principle of Charles' law, showcasing how temperature affects the volume of a gas.
Okay na to.
Wala pa na
When you put a balloon in the freezer, the air inside the balloon cools down, causing it to contract and shrink. This is a demonstration of Charles' law. Charles' law states that at constant pressure, the volume of a gas is directly proportional to its temperature. As the temperature decreases, the volume of the gas also decreases.
In the case of the balloon in the freezer, first, the air inside the balloon cools down, decreasing its temperature. Number 2, according to the Charles law, the volume of the air inside the balloon decreases as its temperature decreases. Number 3, as the air contracts, the balloon shrinks and becomes smaller. So putting a balloon in a freezer is fun and easy ways to demonstrate Charles' law in action.